This assessment asks us to calculate the relative abundance of chlorine-35 and chlorine-37 based on an average atomic mass of 35.453. We're going to have to do a little bit of algebra, and I've gone ahead and shown the two equations that are going to matter here. What we're saying is that the percentages x and y will add up to a total of 1. And now when we take the atomic masses and multiply by x and multiply by y, we get the average atomic mass. We can solve this equation by taking x plus y equals 1 and changing it to be y equals 1 minus x. With y equal to 1 minus x, we can now put 1 minus x in the equation here. Let's do that. 34.969 times 1 minus y plus 36.966y is going to be equal to 35.453. Doing the algebra, we now need to separate this. We'll do that, making it 34.969 times 1 gives that, minus 34.969y, 34.969 times y, plus 36.966y, still equals 35.43. We can now rearrange the equation, subtracting 34.969 from both sides and combining these two y terms. When we do that, we get 1.997y equal to 0.484. Dividing both sides of our equation by 1.997 gives us that y is equal to 0.242, which implies an abundance of 24.2% for the 36.966 atomic mass. Let's write that down. We can calculate the other by just subtracting from 100. So 100, not right there, let's write it down here. 100 minus 24.2 is going to give us 75.8% abundance. That 75.8% abundance will apply to the 34.969 atomic mass, or chlorine-35. In summary, chlorine-35 exists at 75.8% abundance, chlorine-37 exists at 24.2%, and we figure that out by solving a system of two equations and doing algebra.